This is BaslerCast, tutorials for Mr. Basler's physics class. This tutorial we explore the calculations involved in a complex circuit, one containing series and parallel resistors. Let's take a look. This is the circuit from worksheet 2, circuit worksheet 2, number 6. And what I would like you to do is become comfortable with how to solve circuits like this that are both parallel and series, and be able to kind of break it down into the basic steps and how to get started. So this is how you would do it for this one. Regardless of what the readings are, these are the what the values of resistors and voltage are. These are the steps that you'd follow. The first thing you have to do is realize that there are parallel branches in this. And so I consider this blue section here parallel branch A, or branch set A. And it has 3 resistors in parallel, 1, 2, and 3. We can find the total resistance for this parallel branch set by using the equation 1 over R A, which is 1 over total, equals 1 over R1 plus 1 over R2 plus 1 over R3. We have another parallel branch set, which is resistors 4 and 5. You can find the total resistance for those. 1 over RB equals 1 over R4 plus 1 over R5. You can find the total resistance for that section. Now, since those two parallel branches, A and B, are in series with each other, you have to add the total resistance of branch set A and branch set B together to find the ultimate total resistance, R total, for the entire circuit. The next thing you want to find out is the total current. This would be the value of A6. It could also be the value of the current right at this spot before branch A, right at this spot after branch A, and of course anywhere after branch B. You can find the total current by taking the voltage of 1, that's the voltage of the battery, divided by the total resistance, which you just found by adding the two branch sets together. Then, once you have the total current for the circuit, you can find the voltage drop for each branch. So you find the branch voltage. This would also be equal to V2 and V3. You can find that by taking current total times just the resistance of branch A. You can do the same for branch B. Take current total times the resistance for just branch B, and that would give you the voltage for V4 and V5 also. It's also the voltage drop right here for just this resistor and V5 and the whole thing. The last step then is to find the currents, the total currents. These are the current values at each resistor. This is how much current is going through each resistor. You do this by taking the branch voltage, VA or VB, and dividing by the resistor itself. An example of that, if you wanted to find the current at A1, you would take the voltage A, the voltage for the entire branch set, that would be equal to V2 and V3, and divide it by resistor 1.
Okay, now, time to quiz yourself. Using what you've learned so far about how to break these branches apart and find the total resistance and find the total current and then find the individual currents and the voltage drops over each branch, why don't you see if you can actually do this with some actual numbers? Let's start off. We'll make the initial voltage of the battery 15 volts. And then just as an example, let's put out, let's say, every odd resistor, we'll make those 2 ohms, and every even resistor, let's make those 3 ohms. That way you can test yourself and see if you can get the actual values, the voltage drop over the first branch, voltage drop over the second branch, individual currents, all of those. So I will post the answers to this kind of arrangement. Put in 15 volts for your power source for your battery and use these resistance values. And I will post that with the show notes associated with this tutorial. And you can check your work and see how you're doing based on that setup. So go and give that a try. Let me know if you have problems. Come and see me outside of class. We'll check your work, see where you went wrong, if you get stuck. Other than that, happy circuit calculating.